Alright, so in this last proof that we're doing, we're going to write it as a paragraph proof. So those first several we call two-column proofs, and they really just kind of help us gather our thoughts. It's kind of like an outline of a proof. On this one, we're going to just go into a paragraph. So we're going to start by listing our givens. So, given that line A intersects lines B and C, also the fact that line B is parallel to line C, and that the measure of angle 2 equals 130 degrees. Alright, so we're wanting to prove that the measure of angle 2 equals the measure of angle 8. So I'm looking at my picture, and I know, and vertical angles were something you were supposed to talk about in 7th grade, but we know vertical angles are equal. And so I know that angle 2 and angle 4 are vertical angles. I know that 4 and 6 are alternate interior, and then 6 and 8 are also vertical angles. So that's the thought process I'm going as I write by vertical angles. Measure of angle 2 will equal the measure of angle 4. And then measure of angle 4 will equal the measure of angle 6 by the alternate interior angle theorem. And so right now this is where I've got 2 to 4, 4 to 6, and so I'm going to get 6 to 8. And so again, by vertical angles, vertical, vertical angles, measure of angle 6 is going to equal the measure of angle 8. Now, after saying all of that, therefore, by what we call the transitive property, the transitive property, and basically what that means is, so because angle 2 equals angle 4, and angle 6 equals angle 4, then angle 2 equals angle 6. Because angle 2 equals angle 6, and angle 8 equals angle 6, then that means that angle 2 equals angle 6. And so by the transitive property, the measure of angle 2 equals the measure of angle 8. And I know, we didn't use the 130 at all. It is what it is. We put it with it. We are going to go over properties and different theorems to remember so that you have a list, and actually that's what we're doing next. But this all could have been written to column, just like we had before. But when you think about it, no lawyer goes up to a judge and says, well, here's my 2-column, or a jury, and says, here's my 2-column proof as to why the defendant is guilty. It doesn't happen. So they write in paragraph proofs taking that stream of thoughts and putting it down in a paragraph is important. So just putting it out there. All right, so list of properties. So I have started here addition property of equality. That's what I like to call APOE. And so that is when we add to both sides, sides equally. So when we're doing the plus 10, so what could we put here? 2x minus 10 equals 20, and we add 10, That right there is the addition property of equality. Subtraction property of equality, that is SPOE. And so that's when we subtract to both sides. Oops. Equally. I'll try to make sure I'm picking up my pen more than I evidently am. And then our next one's multiplication property of equality, so MPOE. You guessed it. Thank you. Multiply to both sides equally. And then division property of equality, DPOE, depot. That's when we divide from both sides equally. Alright, so we use pretty much most of those in our theorem or in our proofs today. Other properties that would make this easy, we have our associative property, so that's where we're changing our parentheses, so A plus B plus C, or our grouping, who we associate with, just like when you change your groups within school, and it works for both the addition and the multiplication, but it does not work for subtraction or division, so you got to keep that in mind. Oops, C. So this is changing what we're grouping first. The commutative property changes order. I think of commute means we move, or CO change order. So A plus B is the same as B plus A, or 3 plus 2 is equal to 2 plus 3. And it works for multiplication as well. So A times B equals B times A. A and B can A, B, C, they can all be any numbers that are not 0. Identity property, that's where we take A plus 0 and it equals itself, or A times 1 and it equals itself. Whereas the inverse property is when we get, the opposite of this. So A plus a negative A equals 0, or A times 1 over A equals 1. So basically, this is where subtraction and division came in, because they're inverse properties. Distributive property, that's where we have, if we have A times B plus C, that is equal to AB plus AC. We kind of talked about transitive property, so if A equals B and B equals C, then A equals C. So again, they have B in common. And so because they have B in common, then we can say that they are equal to each other. Symmetric property, if A equals B, then B equals A. So this, most of the time we see this when we're doing something like 3 equals X, and we want to write it as X equals 3. That's the symmetric property, the fact that those are both the same. In substitution, the thing I remember with this one, helps me remember it, is when I am replacing. And so if x equals 4 and 2x minus 3, then we have 2 times 4 minus 3. And so we replaced x with 4. So those are properties. These are properties you've worked with some of these before. Some of these maybe you haven't so much. The transitive property is basically just common sense. If two things equal the same thing, then they're equal to each other. This next slide, this is just a list of definitions, postulates, and theorems we've talked about. Midpoint is not on your homework, so it won't be on your test, but I do know that I saw it in some of the homework, so it could possibly be on the study plans. I'm not going to go through each of these. Most of them, all except midpoint, are in your notes from chapter 3. So you can add them here or write what you need to write here about supplementary angles, complementary angles. I just wanted you to have a slide of definitions, postulates, and theorems that we've talked about. But that is it for reasons and proofs. I know that was pretty long, but there's a lot when it comes to proofs. So don't allow yourself to get stuck. Talk to me when you need me. See you on the other side.